In this video, I'm going to go over how to create your own Swift packages and some of the reasons that might be useful in projects. I have a sample app ready to go here to get the current price of Bitcoin. So if we tap the Get Price button here, you could see the current price of 120K displayed above it, hovering right around all-time highs. The file structure is pretty simple here. We have our standard Swift UI app with a content view. And if we look inside the content view, you can see the label for the price. We have the button, and then when the button's pressed inside a task, we're using this Bitcoin service to get the current price. And if we jump in here, it's a pretty standard API call to CoinMarketCap, using an API key, getting some data back, formatting the data into this result, and then using this display string computed property to display the price. This is already completely working as is, but we may have a situation where we want access to the Bitcoin service code from within another app. Maybe an app with slightly different features that has the same core functionality. One way to do that would be to copy and paste the code that we're reusing between apps, but that's prone to errors, and the more places it's used, the worse off it gets. Swift packages are a better way to do this. We can create a Swift package by coming up here to File and going New Package. It's going to be a library. We don't need testing. And we're going to call this Bitcoin package. There might eventually be other things besides the service we want to put in here, so we'll just use this generic name for now. And then we're going to add it to our Bitcoin button project and hit create. So you can see here that we now have this package in the file structure. And if we open it up and check what's in here, we have this package file. This is a file that tells Swift what contents are in the package and describes how we want to use it. And we're going to leave this all exactly as is for now and check out what's in sources. So they give us a default Bitcoin package file here. We actually don't need this. We're going to copy in our own Bitcoin service code. So let's delete this for now. And let's drag in the Bitcoin service instead. And we can now delete the original Bitcoin service since we're going to use it directly in the package. There's a couple of things we need to do to actually use code inside of this new package we created. The first is we'll need to import the package. So if we click on our project up here, and let's actually drag this Bitcoin package outside of the folder to keep it separated. If we click on our project, build phases, and then add this Bitcoin package here, we can tell it that we're going to be using code from the new package. And then we need to come into content service to where we're actually calling it. And we need to import the package. We're still getting an error after importing the package here. Cannot find Bitcoin service in scope. And the reason for that has to do with the way access modifiers work in Swift. Access modifiers control whether or not you can access a piece of code from another piece of code. And there are 5 of them. And we're going to quickly go over all 5 of them, starting from the most restrictive and leading to the least restrictive. The most restrictive access modifier in Swift is private. And what private means is that particular piece of code can only be used from within the same class. So we can actually put a private modifier right here on price text. And since price text is only used inside of this content view, it still works. And this is actually better because it protects the value of price text from being changed unknowingly. So you should always go with the most restrictive access modifier that's possible. The next access modifier is fileprivate, and we already have that in use in Bitcoin service here. The codable result and everything used by the result is marked fileprivate, and what that means is that can be used anywhere in this file. So it's a little less restrictive than private, since you can use it in other classes, but it's limited in file scope instead. Next up is internal. And you'll rarely ever see internal written out because it is the default access modifier in Swift. So when we declare class Bitcoin service, that is the same as saying internal class Bitcoin service. This internal is assumed by default. And what internal means is that code can be used anywhere in the same module that it's declared in. And that leads to the problem that we were having with using Bitcoin service in our project. Because our Swift package is now a different module than our main project. So in order to use this Bitcoin service, it can no longer be marked as internal. So we'll have to step it up to the next least restrictive access modifier. And that is public. So we'll mark this as public. And now this can be used even outside of the module it's declared in. So since we are going to be using Bitcoin service, it makes sense to have it public. We're also going to be using this class function get current price. So this is also going to have to be marked public. So I also copied this secret key value into the package since it was complaining about that too. I'm not going to show that on screen. And now when we rerun the project, we have one error left to fix. Data for delegate is only available in iOS 15 or newer. To fix this, we'll need to limit our Swift package to only iOS versions where this code is available. So in this case, that's iOS 15 or newer. And the way to do that is inside of the package file. We can add an additional argument here called platforms. And inside of here, we can say iOS, only run on iOS version 15 or later. And if we rerun with this change, well, we'll clean the project, make sure the package is rebuilt, run the project, and we can see now build succeeded. It's running on the device. Oh, no, it's not running on the device yet. Now it's running on the device. And we can see the app works exactly like it did before. We don't need it here, but there's one more access modifier that's less restrictive than public. If we wanted to subclass Bitcoin service, let's call it better Bitcoin service, inheriting from Bitcoin service. And let's override the functionality of get current price and just have it always return low by more. And then let's use our better Bitcoin service down here instead. If we run this, we get some errors, and the errors are pointing us at the non-open class Bitcoin service. So if we actually wanted to do this, we would have to come into Bitcoin service and change these public modifiers to open. And what open does is the same thing as public, plus classes can be subclassed and methods can be overridden. So if we now rerun this, this needs to be a class func. Let's run it, and now it works as expected. We don't actually need any of this, so I'm going to delete it and put this back to public like it was before. Public. And there we go. So we now have the app working exactly like it was at the start, but now all the Bitcoin specific logic is inside of a Swift package. So if we ever wanted to reuse this across different apps or different projects, we could save this Bitcoin package to GitHub and then directly use it as a package like you'd use any other package inside your other projects, saving you a lot of time from copying and pasting and also potential mistakes and changes, since you'll only be managing this code in a single place.